Hey Year 4, it's Miss Tildesley again with your maths lesson for today. We are going to be continuing with shape as we were doing yesterday and last week. Okay, so quick quiz, bit of rewind. What vocabulary can you remember from last week? I think I bombarded you with all of this vocabulary yet again yesterday, just to remind you. But what vocabulary can you remember? So I've left these pictures on here. Either write these down in your journals, or just on a scrap piece of paper, or just say them out loud. But what can you remember about the vocabulary that we've been using for the past couple of weeks on shape so far? You can pause the video here if you like. Okay, so here I've got two straight lines, the same distance apart, that never meet. I know that they are called parallel lines. Okay, two lines, same distance apart, never meet. I've got this shape here that has two pairs of parallel lines. Okay, so the top and bottom lines are parallel. The left and the right sides are parallel. And these are this is called a parallelogram. Okay, so a parallelogram is a type of quadrilateral that has got two sets of parallel sides. Okay, then we've got these shapes here that are all quadrilaterals. Remember, quadrilateral meaning four-sided shape. They've all got four sides and angles that are equal. So these types of parallelograms are called are called rhombus. Okay, so a rhombus is a quadrilateral where all the sides and all of the angles are equal. Okay, then we have this shape down here that is again a quadrilateral. We've got four sides and four interior angles. It has two parallel lines, similar to a parallelogram, but it has two lines that eventually will meet. Okay, so those are two lines that are different, not parallel, and that is called a trapezium. Okay, so all of these vocabulary so far we've come across at some point either last week or this week. Okay, then we've got, I've already mentioned this already, but when we talk about the angles that are inside a shape, we call those our interior angles. Okay, so when we're talking about the angles within the shape, thinking about Miss Notes learning last week, the acute angles or right angle or obtuse angles, those are angles that are inside a shape. Okay, and then we have got these different types of triangles. Okay, and I think I've covered the wrong thing up actually, because actually what I wanted to cover up was the names, and I gave you them. So we've got three different types of triangle that we came across last week as well. We've got our equilateral triangle that has got the same amount of sides and the same length sides. Sorry, all triangles have got the same length sides. Honestly, and we've got the same length sides and the same size interior angle. We've got the isosceles that has got two sides the same length and one side that is not the same length. Then we've got our scaling that is completely different. Okay, all the sides and all of the angles are different. Okay, so we've got all of this vocabulary, all to do with shape, all to do with our shape learning. Okay, and we can use these to describe when we're talking about properties of shape. Okay, now we're going to continue our learning on shape. But before we do that, I want you to have a think about this word here. What does it mean by symmetry? This is a word we've come across before. That's why we've got our rewind sign here. But this is a word that we might not have come across since maybe year 2. So I want you to have a real think back, real dig back into your brains to see if you can remember, what does symmetry mean? Okay, you can pause the video here if you like to have a think. Otherwise, I'm going to show you now. Okay, so symmetry, you might remember having a go at something like this. So maybe in FS, you might have painted on one side of a piece of paper and then folded it over. And when you folded it, the same image was printed on the other side of the piece of paper. This will be probably one of your very first examples of using symmetry, because the shape is the same on both sides. So we call that a mirror image. If I was to put a mirror along this line here, this folded shape, it would look exactly the same as the shape that I am showing on this side. So you might have done this in FS, painted one side, folded it across, which means the image on the other side of the shape is exactly the same. Okay, now in year 2, you will have seen lines of symmetry like this. You will have looked at one line of symmetry in a shape. Okay, it might have been a vertical line, or it might have been a horizontal line. And the line of symmetry is drawn across the shape from one side to the other. And if both sides are the same, then that shape has a line of symmetry. If the shape does not. So for example, if I was to draw a shape like this, okay, and I cut it down the middle, actually I fold it here. Does that make it a line of symmetry? What do you think? Thumbs up, thumbs down. Perfect, thumbs down. Because actually, if I folded that piece of paper here, I'd have a lot more left over on this side. This is not a mirror image, an exact same copy of this side here. Okay, I could move my line of symmetry across and I could fold it down the middle. This side is the same as this side, so it does have a line of symmetry. I could put my line here and cut it across here. Okay, that would be a line of symmetry. Both the top and bottom are exactly the same. Okay, does that make sense? So we might have come across, we will have come across this, sorry, in year 2 as one line of symmetry. Okay, so today we are going to be finding lines of symmetry inside a shape. You are going to be moving your learning on from year 2 of finding one to finding more. Okay, so I want you to have a think. What shapes do you know are symmetrical? We've already discovered a couple on this page here. We've already discovered a couple. Are there any other shapes that you know that are symmetrical? Okay, and how do you know if you found a line of symmetry? So thinking about this question here, we know we found a line of symmetry if we were to fold it over, the exact same shape would be on the other side. Okay, we knew that this was definitely not a line of symmetry drawn across there. Okay, because when I folded that, or if I cut that up, I would have a lot bigger on one side and not the same on the other. It's not a mirror image. Okay, so I'm just going to share my screen with you for my Discover today. Okay, and I want to share this one here because what you're going to see is instead of just seeing one line, you're going to see lots of shapes like this today. Okay, this square, it might get a little bit confusing, so I just want you to see the breakdown of it. Okay, so we've got our square, and now a square has more than one line of symmetry. We've gone horizontal from one side to the other. If I go horizontal, I am left with two sides that look like this. Top and bottom would look like that if I was to cut it. Okay, I could also put my line, a vertical line of symmetry, right down from down, top to bottom. And that way, I'd have two sides looking like this. Okay, because this square is equal on all sides, I could also draw a line of symmetry from the diagonal from one side to the other, and again from one side to the other. And that gives me two types of triangles, both the same as the other. Okay, it would be a mirror image. Okay, now the same for my equilateral triangle. There are three lines of symmetry, and I'm going to show you that on this screen here. Okay, because I don't want you to get a bit confused by all of the lines. So here, rather than seeing them all in one go, you can see if I cut a line down this triangle all the way down from top to bottom, so from the top of my first angle down to the center of my bottom line, if I was to fold those up, they would be exactly the same. If I was to fold it up as a piece of paper, I would see nothing on the other side. The edges would meet. Okay? If I was to move that line of symmetry, because this is an equilateral triangle, I could then move that line of symmetry to this bottom corner and do exactly the same again. And it would be exactly the same side. If I folded it up, if I cut it out, they would both be the same size. It's a mirror image. And same again, I can go from this corner to the bottom, and again, I would have the same size. Okay, so this triangle here actually has three because there are three corners, and that's because it's an equilateral triangle. Okay, now I want you to have, and this is obviously a square, is the only regular quadrilateral, remember, because it's got equal sides and equal interior angles. I want you to have a think about this rectangle there. These two both have equal sides, both have equal angles. Okay, do you think with this rectangle, with this quadrilateral, that I would be able to do the same as my square? Will I be able to go from corner to corner? Now, what do you think? Is this a line of symmetry? Okay, hopefully you're now shouting at the screen saying, definitely not, because if I was to fold this over, this corner would be up here somewhere. Okay, so my line of symmetry actually would look something like this. It would actually extend my shape up to there and down to there. okay? So that is not a line of symmetry because it would affect my shape. My shape would look very different then. It would not fold over properly. Okay, remember when I fold it, I shouldn't see any edges sticking out. So this is not a line of symmetry in my rectangle because I cannot go from corner to corner because I cannot fold it over, okay? Does that make sense? Okay, so I'm going to go back to our thing together here. Okay, so we talked about the square and we talked about the equilateral triangles. Okay, now here we talk about triangles have 3 lines of reflective symmetry. Remember, this means a mirror. If I hold that mirror in the middle, it will show exactly the same shape. Okay, the whole shape exactly. Right, what I would like you to move on to is just question. We're not going to do question 1 because we've just talked about that one together, but I want you to go straight into question 2 and I want you to have a think. Now, I've got a hexagon, 2 types of hexagons. I've got a regular hexagon and I've got an irregular hexagon. I know that they're both hexagons because they both have 6 sides. I know that this is a regular hexagon because all of the sides and all of the interior angles are the same, whereas this hexagon is irregular because they are different. Okay, I want you to have a think. How many lines of symmetries do you think these 2 hexagons have? Can you find any? Okay, so how many do you think that these 2 have? And what I would like you to do is, if you can, draw a shape as close to these 2 as you can in your journal. And with a ruler, and it's really important that you use a ruler for this lesson, can you just draw through and see if you can find how many lines of symmetry that these 2 shapes have? Okay, you should notice that, now I haven't got a ruler on this, but the regular, well, that's not very straight, hexagon will have those line of symmetries because it is an equal shape. I can also cut it in half. Okay, I can also cut it in half here, and I can also cut it in half here. Okay, so I can do quite a lot with this hexagon here to find the line of symmetry, whereas this shape, if I cut it down, it's going to be different. If I cut it across here, it's going to be different. I actually can't find any way where I could draw a line that it would be exactly the same on either side. So I can find out that this has lines of symmetry, whereas shape A has none. Okay, because however I draw my lines across shape A, there won't be anywhere that folds and is an exact mirror line. Okay, right, so I want you to use that knowledge today and we're going to have a look at your independent learning. Now, again, because this is the type of lesson there is, it's just best for you to have a go. If you are still struggling and not sure quite what to do, cut these shapes out on a piece of paper. Get a scrap piece of paper, try and cut out a shape as similar as you can, and then fold them. Okay, see if that will work. Because then it gives you a better image, better visualization of whether or not they actually meet perfectly. If they don't meet perfectly, then it is not a line of symmetry. Okay, you will definitely need a ruler for this. Can you find the line of symmetries inside these shapes? Just draw the line neatly. So remember, you're not drawing just one, you're drawing as many as you can find. Okay, so try and do that as neatly as you can. Okay, so you've got an isosceles triangle, a regular octagon, a rectangle, and an irregular octagon in order to find the symmetry. Then you need to find and draw the lines of symmetries in these flags. Now, this is a little bit trickier because I can see that the outside is a rectangle. Okay, but on inside, the pattern itself also has to be symmetrical. Okay, it also has to be symmetrical as well. So you need to think about how you can find the lines of symmetries inside this flag. Okay, because even though I know I could put a line through here to make a line of symmetry for a rectangle, can I do the same for this? And why not? Have a think. Okay, and then question 3. You've got given yourself a table. Now, we've come across this kind of table in the past few lessons. Okay, so we've got 4 or more lines of symmetry, fewer than 4 lines of symmetry, regular and irregular, and you need to put all of these shapes within this box somewhere. So where do they fit? So for example, 4 or more lines of symmetry, regular and irregular shape, I would put my square in this top corner because it is a regular shape and it has got 4 or more lines of symmetry. I know I can go 1, 2, 3, 4. So this square here will go into my regular box here. Okay, all of those shapes should be able to fit in some section of this grid. And then draw an irregular hexagon that has 2 lines of symmetry. So now you've got to think really carefully. Firstly, it needs to be irregular, which means all of the sides need to be, either the sides or the angles need to be different. Okay, and it has to be a hexagon, which means it has to have 6 lines and 6 angles that has 2 lines of symmetry. Okay, so you're going to have a real good go at this. And finally, the challenge. Okay, so the challenge is to draw 3 different shapes, one with exactly 1 line of symmetry, no more than one with exactly 2, and one with exactly 3. As always, please can you share this work with us on Dojo so we can feed back to you and understand whether or not we move on or give you more time to have a go at this. Okay, see you all very soon. Bye.